This conference will now be recorded.
Hope you are able to see my screen. Okay. So today's topic is to introduce Snowflake. This is a demo session, and this is the first session in our course. Okay. Let's quickly start. First of all, I'll talk about myself. I am Lakshmi. Okay, having 13 years of experience in the IT industry. First 7 years of my experience is I worked as a Python backend developer. Later, due to some opportunities, I had to move into projects for data engineering purposes. There, I started my career as a data engineer and learned Snowflake because of project requirements. And I got used to the Snowflake and loved working in the Snowflake. So I thought I could share my Snowflake experience and the knowledge to the others so that it will be useful for them to aspire data engineering positions by the experienced guys and also the beginners. So this is all about me. Let's go into the Snowflake course. Okay. Yeah. I'm opening the slide. Next slide. So what is Snowflake? Okay, you will find lot of definitions in the Google. Okay, telling you what is Snowflake, but I would define it as Snowflake. It's a cloud software which acts like a database, semi ETL tool, and data warehouse. Is absolutely, Snowflake is a software which can act like all of these three. So it can act like oltp database, it can act like olep data warehouse, and through Snowflake we are able to achieve the etl process also. Okay. So then you will now ask me, there are several other ETL tools, several other database and data warehouse. Then what is so special about this Snowflake when compared to with other cloud databases or on-premises databases, right? Yes, you would get that question. Now let me explain you when comparing with the other on-premises databases. Okay, here I have listed out a few of the on-premises databases like Oracle, MongoDB, IBM DB2, SQL, MySQL, right? So we'll take one of the example here, Oracle, and try to discuss some limitations here, and then I will compare that with the Snowflake. So whenever you want to work on Oracle, what generally we need? We need a software in our system, right? The software has to be installed by your IT support team if you have to use a software, correct? If something happens with your laptop or the desktop, you need reinstallation again. This Oracle, correct? And also, for example, your company business is growing and growing, and drastically there is a big surge in the data, right? Then what they have to do, they have to buy new servers which accommodates the extra storage, and also they have to be capable enough of buying the computing machines, correct? So they have to buy extra servers, extra storage capacity in terms of Oracle, and they need some extra physical location. If they have to buy new servers, they need some extra physical location, and also they need resources who maintains that hardware, correct? And also they need power resources, network bandwidth resources, where they have to maintain that hardware power and router configurations, right? And also example, if you take the Oracle, I think you have already seen in Oracle, like for example, user one is trying to insert the records into the Oracle table, then it will not allow other user two to insert the records into the same table because it is already locked by the user one, because user one has not committed yet, so there is a blockage over there, correct? So all these are limitations in the Oracle database. Now let's try to compare with the Snowflake here. So first of all, installation. So Snowflake does not require any installation or configuration, or you do not need any server cost. Okay, you need not to buy any hardware or any storage capacity. You just in fingertips, you can just create the Snowflake account, okay, in seconds, and you can start using it directly. You don't need any pre planning for the physical servers or physical storage, and also you don't need any installations or configuration setup like Oracle needs. Okay, and that is one of the advantage of Snowflake. And also if you have a Snowflake account, you can open it from any of the desktop or any of the laptop. There is no restriction. Of course, there is a network IP whitelisting concept in Snowflake, where you can restrict some IP addresses where you cannot open that Snowflake URL. Okay, there is also that kind of feature. And the other thing what we discussed, one user will be blocked because of other user if user is not committed the inserted records. But in Snowflake, at a single time, simultaneously, thousands of users, even lakhs of users, can insert the records or load the records into the same table. Okay, these are all the small advantages of Snowflake, but we will discuss more and more features which are very beneficial when compared to any other cloud database and on-premises databases. You will know in the next slides the real differences and the real advantages of Snowflake. These are few examples I have introduced. Okay, next. And there are other benefits of Snowflake is, like other ETL tools, Informatica, Matillion, Talent, Amazon Glue, like this, right? And Snowflake has internal connection with these ETL tools. That means if you're already using the Informatica to transform the data, you can use Informatica tool also to load the data into the Snowflake. It has an interconnectivity. Built-in connectors are possible with the Snowflake. Okay, third-party connectors. And Snowflake is introduced in 2012, and it supports data lakes as well, data engineering process, and data science process also. Now in newly, a concept called Snowpark was introduced, where data science, ML and AI, artificial intelligence concepts can also be implemented in the Snowflake. Okay, and I already told inbuilt third party connectors are there. First of all, Snowflake is created on the Amazon cloud provider. Okay, in 2012, when Snowflake came into picture into the public, it was created on the cloud service provider called Amazon, AWS, Amazon Web Services. Okay, but later in 2018, it also came up with Azure Cloud Service. Okay, and later in 2020, it came up with GCP. So that means Snowflake can be created on the cloud service provider AWS, Azure, and GCP. Okay, we will discuss in this detail why they need to be used by the Snowflake. And as I was telling you, Snowflake is a cloud software. Okay, what is this cloud software? That means if you know about the cloud service models, you will understand this better. Okay, so we will call Snowflake as software as a service, SaaS, SaaS, software as a service. So this is a software provided on the cloud, okay, which acts like a database, ETL tool, and a data warehouse. So now you will ask me what is SaaS. I don't know about the SaaS. You will tell me. Then you have to have a understanding on the cloud service providers to understand this SaaS. So let's discuss about this SaaS. Okay, all the service models that are available in the cloud. We will discuss it now. There are three cloud service models. One is IaaS, okay, infrastructure as a service; PaaS, PaaS, platform as a service; SaaS, software as a service. So what are these? Infrastructure as a service. So for any software, or for any software in the world, they need some physical hardware, right, to run the mission, to run on the missions. First of all, what is software? That runs in the background on the physical server missions. So it needs a storage, it needs computing missions, all those, right? But few companies, maybe for example, a company is getting started, ABC company, they do not have a physical location where they can buy the service. They do not have that much budget. Okay, they cannot buy the servers. Okay, they can take it only on the rental basis. Then IaaS will be the best suitable approach for them to take the physical missions and the storage capacity on rental basis. Infrastructure as a service means, infrastructure means physical equipments which supports computing and storage, that is called infrastructure as a service. So ABC can opt for IaaS service, okay, where they can use the physical missions and the storage from the cloud service providers. Who are these cloud service providers? So AWS, Azure, and GCP are the cloud service providers who provides these services on rental basis. They can pay. Amazon will ask you to pay for using their physical machines or storage capacities. So AWS, for example, will take the AWS here. AWS will tell the ABC company, hey, use my machines. You can pay for it. Okay. Then ABC company will opt for this service and pay for its using of physical machines and storage. Pass. Pass this platform as a service. Okay, your physical servers are ready, but you need some platform, right? You need operating system. You need some platform where you can write the code. So, for example, Linux operating system. That means you need some virtual machines on the cloud to write the code, and also you need some GitHub where you can write the code, or you need some PyCharm to write the Python code, or we need some other software to write your code, right? So that is called a platform. So that also can also be provided as platform as a service, where ABC company can use that service to get that kind of virtual missions or platforms, GitHub, such kind of platforms, okay, on which ABC company can allow the developers or employees of their company to write the code. So that also AWS will provide as a service. Next, SaaS. What is SaaS? Directly software. You need not to do anything. You can just install it and software. And few of the softwares you need not to install also. Okay, you don't need any configuration also. That is as a software as a service. That means when you take this service SaaS, okay, that means you are indirectly using PaaS, you are indirectly using IaaS. Okay, fine. So if you are using PaaS, that means indirectly you are using IaaS also. Okay, so let's discuss some examples of these services. IaaS, so Amazon Web Services, Google GCP engines, Azure missions, Rackspace engines, DigitalOceans, and all these are IaaS services. Okay, provides IaaS services to the companies. And PaaS, these are few PaaS services like Windows, Azure, AWS Lambda, where you can write the Python code over there, Heroku, GitHub, where you can write any kind of code over there, and you can store the data in your GitHub, right? These are some of the platforms which allows you to write the code on the cloud, right? And here are few of the SaaS services like Gmail, Picasa, Zoom, Asana, Atlassian, WebEx, even GoToMeeting. Now, whatever you join, these are SaaS provided on the cloud. You can just create an account and use it. You don't need any other configurations, right? These are called software as a service. Since these are provided as a service on the cloud, delivered as a service, these are called cloud service deliverables. Okay, let's go to other slide where it will show other few examples of this SaaS, PaaS, and IaaS. Okay, see, SaaS, HubSpot, Cloud Blue, Verizon, Cloud Scripting. PaaS is Red Hat, Shift Online, GitHub, Kubernetes, Docker, where it is used for the deployment, code deployment purpose, right? Automation of code deployment. And IaaS, infrastructure as a service. These are all few examples of IaaS. This is all about cloud service models. I think now you got a better understanding what is SaaS now. So software as a service. So Snowflake is also software provided by AWS or Azure or GCP for us to use it directly as a software. Okay, right. Now, till now we are discussing what is Snowflake and all, but where exactly this Snowflake can come into picture in the ETL process, right? uh, so ETL as a ETL here. ETL means extraction, transforming, and loading the data. On the left side, you are seeing three databases. It can be heterogeneous or homogeneous. Okay, it can be different. data types also, different file formats also, or different database. One is from Oracle, one is from SQL, one is from Cloud Data Warehouse, anything it can be. Okay, you can extract the data from, right? You can extract the data from different databases and store it in a single location where you will have all the data at one place. What is this data called? A raw data, right? Which is not a useful information. Okay, which is not a useful information. It should be processed. The data should be processed, correct? And it should be transformed into a useful information where it can be used by the BI reporting team. Okay, BI reporting tool to generate the bar charts or some historical graphs, where owner of the company can check out the graphs and take a decision whether our business is growing or having any issues with the business development, and they can take the necessary decisions by seeing that graphs. Okay, first of all, we are extracting the data, transforming the raw data into an useful information. Okay, and then that process data we will put it in the data warehouse. Okay, where exactly the processed data, the cleansed data will be available in the data warehouse, and there you can structure the data like dimension tables and the fact tables, and those dimension tables and fact tables can be used by the BI reporting team to generate the reports. Okay, this is all. This is the high level picture of the ETL pipeline. Now let's go into the detail how this happens. Okay, so on the left side, I'm taking here Apollo Hospitals as an example. Okay, one of the branch. There are three, four branches here on the left side. Apollo branch, one of the Apollo branch, maybe they are storing the data, their patients' data or the doctor's data or outpatients, inpatients' data in the CSV format. And the next branch is storing their data in the OLTP, maybe Oracle, OLTP, online transaction processing. Okay, I'll tell you the difference between the OLTP and OLAP in some time. Okay, right. And the other branch, third branch is using application to store their data. Maybe they are taking the booking their appointments, patients appointments in the application, right? And they are storing that data in the application. And other hospital is using some website, internet website, to store their data. So these are all heterogeneous file systems or databases. We have to bring in all the data into a single location where you will be able to access the data in a single location to transform the data, right? So here we will use ETL tools to transform the data, correct? So any of the ETL tool you can use, but in Snowflake you can also directly connect to the Snowflake using the Python or any other ETL tool, and you can load the data into the Snowflake. First of all, we'll discuss, like, yeah, we have some ETL tool or a Python scripting where you are using to connect to the heterogeneous databases and on the left side, and you connect the Python on the right side to connect to the Snowflake, and you will transform the data using Python from other databases or other file systems or source systems, and you will bring all the data into the Snowflake. That is EDP, Enterprise Database Platform. A single location of entire data is called Enterprise Database Platform. Okay, this orange color database is a raw data which is not a useful information. It may contain an invalid data, unnecessary columns, unnecessary rows, and also invalid data types. Okay, maybe in varchar there are some special characters which are not suitable for the processing. Okay, for generating the reports. All this kind of invalid data is present in on the left side EDP. Now this has to be transformed into a useful information, right? What kind of transformations you will do, the data present in the EDP on the raw data. So what is transformations? Okay, cleansing the data, that means avoiding unused data. Maybe you don't need some records, or you don't need some columns. You can avoid that, you can filter out that columns using where conditions or something like that, right? Whatever the process you follow to cleanse the data, uh, So you can remove unnecessary data. And validation of data, is this column having the right data type, is this column is having the right information. For example, in the city column, is it really having the city information? So all these kind of validations you will do. And if it is not having, either you will change the column name to the suitable name, or you will try to push that code into the right suitable column. So all these kind of transformations. Next, creating new columns out of two columns. For example, they saved their data like first name and last name, and you wanted to bring it as a full name, right? That is also one of the transformation. You are combining two columns into the new column. And also, maybe you want to filter out some columns. Okay, you want to remove the columns, you don't want to bring that into the processed information, so you will just avoid the columns. And you want to fill in with some default values. For example, if they didn't fill anything in the gender, you want to by default save it as male, or you want to save it as F. Or if they did not save country as anything, you want by default you want to save it as India. So that kind of default values you can do. Or you want to save it as null values by default. Okay. And also, you want to change the data types for particular columns, you can do that also in the transformations. Or you have four tables here. For example, on the orange color, you have four tables, right? You brought in from four branches, and those four columns now transformed into six tables here. Why? Because one of the table maybe need a split. They want to split the table like a if there are, if in that table they have 10 columns. Okay, 10 5 columns they divided into one table, and the other 5 columns they divided into the other table intentionally because of some business requirement. Okay, so these kind of splitting of the table also is one of the transformation. And for example, you have two tables and you want to join them into one table, that is also one of the transformation. So all this kind of cleansing of the data and sorting, you can do even the sorting if you want to do. Okay, so all this kind of cleansing, massaging and transforming the data. Okay, once it is done, now your raw data is a processed data, it's a useful information. Okay, now you will store the transformed data into the EDW, enterprise data warehouse. Okay, that is OLAP. OLAP means online analytics processing. That means this data is now used for analytics purpose. Okay, so this is called online analytics process. What is OLTP? The real time data. Real time data is stored in the OLTP. So OLTP cannot store years of data. It can store maximum 6 months or only few months of data. It can store only GBs of data. OLTP. It will always replace with the new data, with the new transactional data. But OLEP is not like that. OLEP will store the entire history of the data, many years of data. It can store TBs of data, pegabytes of data. OLEP, right? Okay, your entire data is in EDW, like at data warehouse. Now, what you will do with this data? Maybe your based on your requirement, you want to segregate the data into multiple data marts. Okay, maybe Apollo is choosing to store only doctor's information in data mart 1, and patient's information in data mart 2, and nurses information in data mart 3. So they can segregate the data based on their department, and they can use that chunk data mart to some other BI reporting team. Okay, it's not mandatory to create the data marts for every company, it's their choice. Okay, even BI reporting team can also bring the data or fetch the data, retrieve the data from the data warehouse directly if the files are well structured. Okay, based on their departments, it's not mandatory to create the data marts. So this is, and this data mart, the data marts or data warehouse are used by the reporting teams like Tableau BI tool or Power BI tool, Looker tool to create the charts. Okay, this is all completely extract, transform and load. Now, okay, I explained the entire ETL process. This is also the same diagram. The only difference here will be the data lake. So what is data lake here? Okay, data lake means here what I did all the transformations to store the data into the data warehouse, right? So that is a data warehouse. But data lake do not have any processed information. It stores the raw data. Okay, it keeps on stores the raw data in the data lake. Why? Because for future purposes, maybe some companies will prefer to store the data in the data lakes without any transformation, keep the raw data as is, the historical data. To maintain the historical of data, they will maintain the raw data without any transformations. That is called data lake. But if you data warehouse contains the processed information, right? And where exactly Snowflake fits into this entire process? So Snowflake will do, can do, okay, can do extraction of data, transformation of the data, and loading of the data, and also structure the data, organize the data. That means data modeling can also be done in the Snowflake, and also data marts can also be generated using the Snowflake. So this entire process can be done using the Snowflake. Okay, this is where Snowflake come into picture. Okay, in the ELT process. Okay, fine, I'm going to the next slide. Yeah. Now, okay. There are other ELT tools and data warehouses, and why I have to choose Snowflake, and why Snowflake has become so popular nowadays when compared to other cloud data warehouses, and it has become quickly popular, right? Than any other cloud data warehouse. I think after Informatica, Snowflake has become so popular now, right? Why? There are very very good features in Snowflake, and there are many reasons why Snowflake. I can say there are many reasons why Snowflake has become so popular. Here I have listed out few here. These are only few. Web UI. First of all, we'll talk about the web UI. Snowflake web UI. So web UI is a Snowflake snow site. We will call it as a snow site. Okay, snow site web UI. This snow site web UI can be used like any way in the Snowflake. Like you want to create the database, you want to create the table, or you want to load the data into the table, or you want to create physical missions, not physical missions but virtual warehouses. They will call it as computing nodes. So if you want extra computing nodes, you can create it, or you want to scale it, you don't want that much physical missions, everything can be handled using the web UI. You can create roles, you can create users using the web UI. Whatever you can do with the SQL commands, it will all Snowsite also supports through web UI. Okay, you can create you can do anything. And also in web UI, one of the important feature is query profile and query history. So if you if you compare with any traditional database or traditional data warehouse, do you have a query history where you can see what is the query you executed 10 days back, right? No, right? But in Snowflake, you can see 14 days of query history to 10 days back to which I executed it. The query, I can check it. I can check the error. I can check where exactly my query has taken time, 10 days back. So everything you can check using the web UI. And also you can see the history, which table has loaded 10 days back. Okay, and which file we loaded, which size, what is the size of that file, how many rows were inserted into the table successfully, and what are the rows failed, what are the rejected records, everything you can check in the web UI using the web UI. That is one of the advantage of the web UI. And performance, this is one of the most important feature why Snowflake has been preferred by the companies. Performance, compared to any other cloud data warehouse or cloud database, executing a query, a complex query, can be executed within minutes, 1 minute or 2 minutes. Okay, no other cloud data warehouse or cloud database can give this performance more than 10 times faster than any other. Snowflake is 10 times faster than any other cloud data warehouse. And also it loads the data within seconds. How much data you give, like 1 GB data, 2 GB data, it will load the data in seconds, not more than a minute. It will load the data in less than 1 minute. And concurrency, as I already told you, 1 lakh of users, thousands of users can load the data in the same table at a time. Many users can use a Snowflake at a time. A same virtual warehouse or multiple virtual warehouse can be used by the multiple users uh, in the Snowflake. Scalability means here, uh, what do you say? For example, you still till now you are using 1 GB of data, but your business has grown in this month, and you have to store 5 GB of data. You need not to buy anything, the storage, or you need not to ask Snowflake permission. Hey, I have 5 GB of data more in this month, like that. Snowflake will automatically allow you to store the data as much as of your data, GB data, TB data, petabytes of data. It will not restrict you to store the data. It gives you unlimited scalability. That scalability is possible using the in terms of storage. Okay, but you have to pay for it. That's it. You have to pay for it later, okay, based on the billing, right? And the another scalability is, for example, there is for example, one computing node you are using. Okay, I'm not using the term virtual warehouse here, because later you will know more about the virtual warehouse. Virtual warehouse is nothing but a computing node which executes a query. So for now you have only one computing node which executes a query, but there are thousands of users and lakhs of users are getting added. Okay, then one computing node is not enough for you to execute the queries. So simply you can add one more computing node without asking permission to the Snowflake. And you can add as many as computing nodes. Even sizes also, you can add more sized computing nodes, so that it can accommodate multiple users. It can accommodate large GB of data loading, large TB of data loading. It can scale the hardware, it can scale the storage based on the workload. That is called scalability. Pay as you go model. That means if you are using two computing nodes, yes, of course, you will be charged for that. But Snowflake will not restrict you to use it. You have to pay. You have to pay if you use it. Pay as you go model. Unlimited storage. As I told, it will not restrict you to store the data. You can use as much as data you want. Okay, snow pipes. This is one of the beautiful concept in the Snowflake, where you can load the data from cloud storage into the Snowflake automatically on a schedule basis. Okay, once you created the snow pipe, it will automatically detect the data in the cloud storage. If any file newly created on that cloud storage, it will automatically detect the data from cloud storage and load the data into the Snowflake tables automatically. This is one of the feature inspired and attracted the companies to use the Snowflake. Data sharing. This is also one of the important feature which attracted the companies. Means once you have a table or a database in your Snowflake, okay, you can share that database or a table to another Snowflake account without any restriction. Without any restriction. So of course you can share only few tables from the database. You can share only few views. It's up to you. If you want to share the entire database, that is also fine. And for creating this share to other Snowflake account, you will not be charged by the Snowflake, and the storage will not be occupied if you share that data to the other database. And the a provider, means there are two concepts here, provider and consumer. Provider will create the share on her database, okay, and that database will be shared to the consumer. And if consumer selects the data, means query the data from that database, provider will not be charged, only consumer will be charged. And consumer will not be able to do any modifications or changes in that sharing. So as soon as provider makes any changes on this table, on this database, immediately consumer will be able to see the data. Live sharing, that is why it is called live data sharing. There will be no delay, not even a second delay will be there when you have updated data in the table, and consumer can view the data immediately. And a decoupled storage and compute, as I was saying before, you can increase the storage, increase the compute. So you can increase the storage and compute independently. It is not mandatory, or if you increase computing nodes, it will not increase the storage. If you increase the storage, it will not add the computing nodes. So they are interdependent. Okay, they are decoupled. But in Oracle, how it will happen? If you want to add extra servers, storage and hardware like computing machine, servers, processors should be added. Both should be bought together, right? But here it's not like that. They are decoupled. Easy maintenance. There are several things that can be maintained easily in the Snowflake. I'll just say few here. One of the thing is, there is no software installation needed. That is one of the easy maintenance, and you need not to take any hardware maintenance. Snowflake will take care of it. Okay, Snowflake will take care of it. And you want to save the storage, because maybe you have in the CSV file you have 1 GB data. Okay, but you don't want to use entire Snowflake storage of 1 GB. Okay, so Snowflake will take care of saving the storage by compressing the data. That 1 GB data, it compresses the data in the Snowflake and it will save the storage for you. It will automatically compress the data. It will automatically encrypt the data. And so these are all easy maintenance. And also you can the other thing is worksheets. Okay, whenever you are doing some work on the worksheet, means just like for example you use SQL editor, right, in the Oracle. So you will have an editor here, worksheet, so you can write as many as queries you want in the worksheet, and they will be automatically saved for you in the versions. So 5 minutes back, what is your code? 6 minutes back, what is your code? 10 minutes back, what is your code? And 1 day back, what is your code? Everything will be saved in the versions. You can access that versions for your older queries, and that will be automatically saved. You need not to press the Control S. And next day, if you come and open that worksheet, your code written 2 days back also will be there in that worksheet until and unless you delete it. That is called easy maintenance in the Snowflake, and handles multiple data types. That means it handles CSV, it handles JSON, it handles XML, Pocket, every kind of semi-structured, structured, unstructured data also will be handled by the Snowflake. Easy backups means you can take the backup of the table without any storage cost. There is a concept called cloning. So you can just create a clone out of the existing table so that you will have a backup. Okay, and for storing that backup, it will not cost you the charge. Storage will not be occupied for that cloning. That means it's an easy backup, and budget oriented backup you can take it. Okay, and easy data recovery. This is a beautiful concept in the Snowflake. And what do you say? This is one of the main reason why companies are preferring the Snowflake. Data recovery means if you lost the data, like for example, if you deleted the table mistakenly, okay, mistakenly, now you dropped the table, drop table and table name, right? That's how you drop the table. What will happen if you drop the table in the Oracle? You cannot bring back that table, right? And you have to go to the admin support team. Hey, I dropped the table mistakenly, or I have changed the table mistakenly. Can you please restore the historical data? That's what you will ask your admin support team, right? But in Snowflake, you need not to ask anybody. You can just do undrop table name. That's it. You will have your table back. Okay, and also for example 2 days back you made some change, and today you realized, hey, I made some mistake yesterday. I updated wrong records. Instead of changing department number 10, I changed department number 20 2 days back. I want to revert that change. Of course, you can bring back the data like how it is before 3 days. You can bring back the data. That is called easy data recovery within seconds. If you write a SQL command for this, you can a small SQL command, that to one line of code, One line of code will bring you all the data you want. Okay. And highly secure, as I said, Snowflake will encrypt your data. Unless you execute the SQL queries through third party connectors or directly from the Snowflake side, you will not be able to see the Snowflake data by any customer. You can see the data only by select queries. Okay, by only DQL operations. Next, and also there is a multi-factor authentication mode where you will get a password to your mobile. Okay, you will get a password where you can enter that password and log in into the Snowflake. That is one of the secure factors, security feature that Snowflake has enabled now. And vivid documentation, this is really my favorite feature of Snowflake. Not feature, it's one of the advantage, right? So it has such a documentation of Snowflake. Everything we discussed as of now will be very detailedly explained in the documentation, Snowflake documentation page. So not only these, practically SQL queries, what you can do with the web UI, what you can do with the SQL queries, how to create a table, how to create a file format, everything, what not, everything will be available in the Snowflake documentation. And it will be very useful when you are working in the real time, as well as if you want to prepare for the certification. That preparing using that documentation is enough. Such kind of documentation we have for Snowflake, and I bet there is no such kind of documentation for any other cloud data warehouse or cloud database or on-premises database. This is one of the biggest advantages of Snowflake. Even beginners can start using this documentation and learn Snowflake. SQL skill. This is not a feature of Snowflake, but one of the reasons why companies are preferring to use Snowflake, because already the people have employees have SQL skill, and if they have SQL skill, they will understand the Snowflake easily. Okay, so that is why companies, hey, I have employees of SQL, so if I want to move the data into the Snowflake, these people will be helpful because they will understand the SQL easily. So that is why they are preferring to move the data into the Snowflake, because of advantage of SQL skill. Okay. Next, these are all few of the reasons why Snowflake became so popular in the world. Okay, and these are few, here only I listed few customers, Snowflake customers, and nearly more than 10,000 customers now for Snowflake. Okay, and it keeps on increasing. Okay, they are preferring Snowflake to use. Okay, and which Snowflake architecture Snowflake is using. Okay, every database will have an architecture, right? So what kind of architecture Snowflake is using? This is tradition. First of all, we'll discuss about the traditional DB architecture, and later we'll talk about the Snowflake DB architecture. In on the left side, you are seeing shared nothing and shared disk, right? Okay, what is shared nothing and shared disk? Shared nothing means every node means a computing node, a machine. Okay, every node will have its dedicated storage. Okay, node 1 has storage 1, node 2 has storage 2, node 3 has storage 3. So node 1 is solely responsible for storage 1. It cannot access the data from storage 2 or store the data in the storage 2. Only it is responsible for storage 1. Okay, and it is easy to scale the mission, like how if business is growing and they want to add a mission, they can add node 4 and storage. That's it. Scaling is easy, but of course it is a costly approach, right? And they will maintain backups here, like for example, storage 1 has all the data that is stored by the node 1, but to have a backup of the data, it has to add one more database, which is a costly one. That means node 1 should have two, node 2 should have two, node 3 should have two storages for having a backup storage. So data redundancy is a costlier one, no data redundancy. Okay, and if node to lose the connection for some reason, or lost the connection because of some reason for the storage 2, then it lost. If there is no backup, node 2 is not able to get the data for the users. There is a failure over there, right? But here the advantage is data segregation. HR department can be handled by storage 1, storage 2, other department. So data segregation is easy, but metadata maintenance is little bit difficult, because different data is available in different storage. Somewhere you have to maintain the metadata, right? Hey, this storage has this department, this table has is there in this storage. So all this kind of metadata you need to maintain in some location, right? So it is little difficult to maintain the metadata share in the shared nothing. But if you go to the shared disk, okay, uh, node 1 will have access to three databases: storage 1, storage 2, storage 3, like the way node 2 also. So if node 1 has a failure with storage 1, it automatically changes its connection to the storage 2. It maintains the redundancy. Okay, and concurrency is possible. At a time, node 1, node 2, node 3 will be able to access the storage 2, right? Concurrency is possible. And metadata, easy to maintain, because every storage has every data, right? So every storage will have its metadata ready. So metadata maintenance is ready. Data redundancy is also possible here, correct? There are three databases, and we are utilizing three databases for data redundancy also. But there is a disadvantage of locks. So for example, node 1 is trying to insert the records in the storage 1 table, and node 2 is also trying to insert the records in the same table. Node 2 will be logged, node 2 user will be logged. And if at a time all the users are trying to execute the same storage, same table, then there will be a low performance. So there are certain advantages in the shared disk and also disadvantages. In the same way, shared nothing has its advantages and also disadvantages, right? So then, what Snowflake is using, right? It's a combination of shared disk and shared nothing. Means it is taking advantages from shared disk and advantages of some shared nothing, and combining into a modern architecture. If you closely look at the picture, these virtual warehouses are nothing but nodes. So multiple nodes are able to access the single storage like shared nothing, but having different partitions of data. This data is in single location, single storage location, but having different partitions where like shared disk. So each node can access each partition, but in a centralized location. So it is able to give the advantages of shared disk and shared nothing. Concurrency is possible. Multiple virtual warehouses can access the data. Metadata data maintenance is easy because of single storage location, means a single centralized database location. And there will be no locks, because they have different partitions over there. Data segregation is possible, and scalability is possible. If you want one more node, you can just add it. If you want one more partition, you can add it. So scalability is possible. So all these kind of advantages brought in and designed into a modern DB architecture. So let's closely look at Snowflake architecture. See, in future sessions, we will discuss very deeply about the Snowflake architecture. But now I'll try to give you a high level picture. Okay, Snowflake architecture has three layers, right? First is cloud storage layer. Okay, cloud storage layer where the actual data of Snowflake will be stored. Okay, fine. Now, where exactly this data is stored? Till now, I am saying, hey, Snowflake will store the data. Snowflake will store the data, right? But Snowflake do not have any dedicated data centers to store the data. It will take the help of one of the cloud service provider to use their data centers. For example, if Snowflake account is created on the cloud provider AWS, then Snowflake will store the data in AWS S3 buckets. Okay, if Snowflake account is created on Azure, then Snowflake will store the data in Azure blobs. If Snowflake is created on GCP, then it will store in the GCP storage. So whenever user is loading the data into the Snowflake, they will go and sit in AWS S3 buckets if the Snowflake account is created on AWS. So that means here the conclusion point is Snowflake do not have dedicated storage locations, dedicated storage centers. They are taking the help of cloud service providers to store their data. Okay, this is about cloud storage. Cloud, now computing services layer, this is also called as query processing layer. Compute means processing, right? Query processing layer. So here the hardware will be existing. Okay, who, what is this hardware will do? Okay, they will execute the queries, they will process the queries, they will load the data, right? Who is going to do that? Virtual warehouses, computing nodes. Virtual warehouses are nothing but computing nodes, those will do that. But does Snowflake really have that physical missions? No. Again Snowflake is taking help of AWS EC2 missions. Okay, they are taking the infrastructure as a service, infrastructure IaaS. Okay, machines and storage, both IaaS, they are taking help of machines and storage for doing their job. So here virtual warehouse means if the Snowflake account is created on the AWS, it is using EC2 missions, AWS EC2 missions to process the queries. Again Snowflake is depending on the AWS. Okay, virtual warehouses is nothing but a cluster of group of nodes, means it if, one cluster contains multiple nodes. Okay, in future you will understand this virtual warehouses very clearly. Okay, okay, now cloud services layer, this is the brain of Snowflake. Okay, everything will be handled in this cloud services layer, like access control, your username and password, creation of users. Okay, once you logged into the Snowflake, who will take care of that authentication and all, right? Access control will take care of that. And infrastructure, which virtual warehouse should execute the query, with in which database the data has to be stored, the user has inserted the records. All those infrastructure maintenance will be done by the infrastructure component. Transaction management means, see, another advantage of in the Snowflake is when you insert the records into the Snowflake, you need not to commit the records, it will automatically commit you the records. You need not to worry about the loss of data while you're inserting the records, it will automatically insert that, commit that. Who will do that? Transaction management will do that. Optimizer is a planner where whenever user is executing the query, optimizer will check that query whether it has any syntactical errors or any table related errors, something, right? If the table does not exist, so all this kind of checking will be done by the optimizer. When it feels right, hey, yes, this Snowflake query is correct, then optimizer will take care of asking virtual warehouse, hey virtual warehouse, please execute my query. Optimizer will do that, planning will be done by the optimizer. Okay, and security, as I said, encryption of the data and access, this table can be accessed by only few users or few roles. That kind of security related things will be taken care by the security component. Metadata component means metadata, where metadata, what is metadata? Data of data, right? Which table is existing in which micropartition. Don't think about the micropartition word now. Micropartition is a memory location of the storage. Okay, so in which memory location the data has been stored, like what are the number of columns of that table, what is the name of that table, and how many rows are there in that, what is the minimum value, what is the maximum value, everything will be stored in the metadata. So if you are giving the query like select a min of something, min of salary from employees, it will not go and execute using the virtual warehouse, it will directly bring in from the metadata. So it will save you the time, it will not go to the storage and come, It will directly give you from the metadata. Then where exactly this metadata is stored? It is stored in the FDB, foundational database. It is one of the database, open source database used by the Snowflake for storing the metadata. Okay, it is an open source database. Okay, and it is not help of AWS. It is an FDB, an open source database, and only how much metadata needs the data, maximum MBs, that's it, right? So Snowflake will store that MBs of data, metadata, in FDB. This is all about the Snowflake architecture. Okay, next let's go into the next slide. Yeah, this is one more view of Snowflake architecture. This is a centralized storage location having different partitions. These are virtual warehouses. Okay, these are virtual warehouses, and these are cloud services layers, metadata, security, transaction management, optimizer, all these. Okay, gray color one, right? Next, and I was saying, multi-users can use the virtual, multi-users can use the Snowflake at a time. How that is possible? So they will create a separate virtual warehouses for different roles. For example, he is responsible for creating the reporting tools using the Tableau, and he is trying to connect to the Snowflake. So he is going to use a dedicated virtual warehouse. Okay, and this data scientist will use a separate data warehouse. Okay, and this talent separate warehouse, and Looker separate warehouse, while trying to connect to Snowflake and get the data, and each will be maintained a separate data partition. Okay, data partition. So this guy will not be interrupted or disturbed by another, not blocked, or performance degrade, or performance will not also be degraded because of separate virtual warehouse. Her job is hers, her job is hers. So there will be no interaction between multiple users. Everybody can use their separate virtual warehouse. And there will be no limitation on how many virtual warehouses you can create in the Snowflake. You can create as many as, okay, you can create one for testers, you can create one for developers. And if you want, developers are using most of the they are loading the data, GBs of data every day, then they will use bigger size virtual warehouse, but testers will not use that much, right? So they will have a separate virtual warehouse with a lesser size. Okay, you will understand about the sizes later when we are discussing about the virtual warehouses. Okay, right. This is how multi means concurrency is able to be achieved in the Snowflake. And these are some of the Snowflake partners which are already connected to the Snowflake. So if Fivetran, Talent, Switch, Sigma, all these, so they are already connected to the Snowflake. If anybody using these tools, they can easily use the Snowflake. Okay, and skills required to learn Snowflake. Sorry. Okay, skills required to learn the Snowflake. It is to understand the Snowflake, you should have a good knowledge on SQL. Okay, and without knowledge on the SQL, you will not be able to understand the SQL queries. Of course, you can know the Snowflake features and all. You will understand the concepts of Snowflake, but to be comfortable in the real time, to do the work on your own, you need SQL knowledge and procedures knowledge. Procedures, it's not mandatory. All companies may or may not use the procedures, but it is good to have a procedures knowledge. In this session, in this course, we will discuss the procedures as well. Right. Decent knowledge on ETL and data warehouse concepts. It is good to have knowledge on ETL process and data warehouse concepts, so that you will understand data loading and transforming the data in the Snowflake easily. Okay, I recommend to gain some knowledge on the SQL and ETL and data warehouse concepts before you start course on the Snowflake. And it's an added advantage to have Python scripting knowledge. Nowadays, companies are preferring to have Python knowledge, because it's an open source scripting language, right? You need not to pay anything for Python. So what they are using, instead of paying for ETL tools, they are using Python to extract the data from different sources to the Snowflake. So Python is the easiest one. Of course, coding, if you are not from the programming background, you will feel difficult. But once you learn the Python, it will be very easier to connect to the other sources and bring the data into the Snowflake. And it is free. Companies, that's why they are preferring Python to connect to the Snowflake and bring the data. So these are the skills required to learn the Snowflake. Okay, that's all. We are done with the session. If you have any questions, please you can ask me. I'm stopping the recording.